Okay, so circles, Euclidean geometry, with that goes hand in hand with tangents. So when we look at tangents on Wednesday, I will remind you of a few important things about tangents, but like I say, the important stuff in terms of analytical and gradable is very much using circles on your Cartesian plane with these formulae that we have. Okay, so if you have a look again at this little orange block, sorry, these are all your analytical formulae. So we have already spoken about the first four. We've used those a fair amount in our previous lessons. If we just make it a touch bigger. If you can hear screaming, I do apologize. They're playing basketball and my classroom is literally on the court. Okay, so we have got four formulas that we know thus far. And we need to be able to apply all of them. So it's all well and good having these formulas, but if you don't know how to work with them, then it doesn't really do much for you. So our first formula here is our gradient formula. I know you know this, but I'm just writing it down because you don't want to be feeling stuck. The next formula just down at the bottom, the tan theta equals m. This is for your angle of inclination. D is your distance formula. And M, capital M, is your midpoint formula. Again, you get this all on your formula sheet, but it doesn't help if you don't know which is which, because unfortunately you can't ask an invigilator, oh, which formula is which. They can't help you. So yes, they're on your formula sheet, but you do need to know what's what. Okay, but the formula we're going to have a look at today, or that we're going to start working with quite a lot, is this formula over here in pink. Terrible choice of highlighter, but here we are. And this is the excuse me, the circle formula. Right, now I'm going to explain what each of these parts mean, but this is the formula for a circle. And this we're going to work with a fair amount, like I say, over the next 2 weeks. Okay, so if we just shove down a bit and we go and have a look at a circle and its formula and what this all means. Okay, so this formula that we have here is called, or is in the form, center radius form. Now, the reason I'm making a point of this is because remember, like with any formula, you get a standard form. For example, if you think of like your parabola, you get a turning point form, you get an x-intercept form, you get a standard form, ax squared plus bx plus c. So there's different forms of formulae depending on what you do with them. If you were to expand your brackets out in this formula, you would just have your standard form. This is your center radius form. This form of your equation gives you a lot more information than your standard form would. I'll show you what the standard form is as we sort of get into it. But having the bracket squared equals to r squared gives you a lot more information about your circle. So what information does it give you? So these points A and B, does anyone know what information that gives us? Put in the chat or you can unmute yourself. What information does the A and the B give us for our circle? Nice, Leila, exactly. It gives us the point or the coordinates of the center of our circle. Excellent. All right, so that is essentially what this coordinate gives us. A is your x coordinate, B is your y coordinate. What I need you to remember though is that it's a counterintuitive thing again. So like with the shifts left and right with your graphs, it's the same idea. So if, for example, your bracket was x minus 1 squared plus y plus 2 squared, your center uses the opposite sign. So the center x coordinate would be positive 1 and the y coordinate would be negative 2. So like I say, it's counterintuitive. You use the opposite sign when you write down your coordinate, and you can see that there as I've written down positive A and positive B rather than negative A and negative B. Right, r squared gives us information about our radius. Okay, oh, what an honor. Your radius, as we well know, is the line drawn from the center of your circle to the circumference touching once. If we extended that radius all the way through the center to both ends of your circle, you would have this the circumference, the diameter. All right, so this bit of information that we get here is very, very important when it's in the center radius form, because we can get not only the center point of my circle, but how long the radius is. And we'll get some questions a bit later where it's really important that we know how long the radius is, or what the distance from the center to the circumference is, because it's going to be able to tell us whether or not a point lies within a circle, whether or not two circles intersect or touch. So understanding the distance between center and radius, center and circumference at a point, is very useful and very important. Okay, so that's just sort of the basics of a circle, right? You've got a center, you've got a radius, and the form that we generally write our equation in is our center radius form. Not necessarily always, but 90% of the time it is. Right, I don't know if you want to take a screenshot of this, but we're going to have a look at some examples where we just do some basics. You're going to practice quite a lot today, but we are going to get into more complex stuff. I'm just waiting in case anyone wants a screenshot. Okay. Right, so let's have a look at our first example. So for all of these, I think there's 5 of them, if I'm not mistaken, ABC, yeah. We just want to write down the center and the radius. Now remember, your formula is x minus a squared plus y minus b squared equals r squared. So it's radius squared. Bear that in mind. If you wanted the, sorry guys, if you wanted the radius, you would need to square root that value. So if we look at the first question, we can easily find out what our center is, because our center is the a value and the b value. Remember, the signs are the opposite, so it's +1, -3 for my center. But now when I get my radius, what I need to remember is that, I'll move it up now, don't worry, is that I need to square root the value. So I need to take 25 and square root it. Now, remember your radius is a length, so it's always positive, which means your radius for the circle is 5 units. Cool. Right, so really nothing too tricky, really nothing that you need to think too hard about. Oh. Yeah, guys. It is what it is. Okay, let's just do this. 5 units. Okay, so we've got the center and we've got the radius. That's all we need to stress about. Right, if we have a look at question B, maybe not. Okay. Who can give me what the center is and the radius of the circle? So I just need a coordinate for the center and the length of the radius for the second circle in question B. Remember, I want the center and I want the radius of question B. Nice, Simtanda, Leila, very nice. Okay, good, guys. Remember your center, opposite sign, so -2, -9. Your radius, you would need to square root 100, so your radius is 10 units. Perfect. Okay, so really not too tricky, and just by having your equation in this format, like I said, gives you a lot of information. You can start to visualize what your circle looks like. Right, if we now look at C, this is a bit different, because if we go and have a look at the x term, you just have an x squared. In the last 2 examples, we had a bracket that was essentially a binomial of x plus or minus a value squared, and then a second bracket of y plus or minus squared. When you just have x squared, can anyone tell, I don't know if I can speak English today either. Can anyone tell me what that means in terms of the x coordinate of the center of your circle? So if we just have an x squared, what does that mean about the x coordinate of the center of your circle? Nice, Leila, excellent. X is 0. Okay, so if there is no bracket with an x minus or a binomial containing x, all this means is that your circle's x coordinate is at 0. So basically the center will fall on or will lie on the y-axis. I had to second guess myself there. So for our center, we know the x coordinate is 0, the y coordinate is 1, so that's what I'm saying, it's on the y-axis. And then nice and easy, our radius here, 7 units, we just square root. Okay, so anytime you've got an x squared or even a y squared with no other x or y term, all that means is that your circle passes through 0 on either the x or the y axis. Okay, so with that being said, what is the center for question D? And if you want to go a step further, what is the radius? Nice, Leila. Okay, guys, so good. Because there's an x squared and a y squared, and there's no x or y terms. It's just the x squared and the y squared. What that means is that our center sits at the origin. And sometimes in the question, we will say with the circle centered at the origin. And then exactly as you guys have said, the square root of 81 is 9. So our radius is 9 units. So just remember, if you just have an x squared and no x term, just a y squared and no y term, you are looking at a 0 for x or y respectively. Okay, so when we then get to question E, this is nice and easy because we've done this. We can see that our center is at positive 3, 0. Remember, it's always the opposite sign. And your radius now, you don't have to say you can guess yourself or question anything. You just take the square root of that value. Yeah, it's not going to be a nice number, and you can write it in decimal form if you want. But as long as you are always remembering to square root the radius or the r squared value, you have got the length of your radius. Okay, so it seems really tedious, and it seems like I'm literally just reading information off, yes. But what you need to remember is that 9 times out of 10, we're not going to give it to you in this form, and you will have to go and do something a little bit extra in order to figure out what your center and what your radius is. I'm not saying that we can't give it to you in the center radius form, but 9 times out of 10, we don't. And we ask you to write the equation in a specific format, or we give you the standard form and ask you to find the center and the radius, which we're going to get to. Right. So take a screenshot of this first example, and then we'll move on to the second one. I don't remember if you try or not. And like I say, guys, this is straightforward. It's not supposed to be super tricky yet. It's going to get harder. So we need to know the basics before we can go and step it up a level. Okay. All right, so in example 2, we just have 3 questions here. All I want to do is write down the equation of the following circles. And in a question like this, I would say in the form x minus a squared plus y minus b squared equals r squared. So I would tell you what format I wanted the circle's equation written down. In this case, that's exactly what I want. Now I'm giving you all the information that you need, so you don't need to think too hard about it. Just remember your center sign should be the opposite. So our equation here would be x minus 2 squared plus y plus 3 squared is equal to, and because our radius is 8 units, we're looking for r squared. And so that would be 8 squared, which is 64. Nothing tricky. We are substituting straight into our circle equation. We're just remembering that the center's coordinates should be the opposite sign, and that we need to square our radius length. Okay, so when we get to something like question B, this shouldn't be too tricky. We've already discussed what happens when it's centered at the origin, but so that you can see what happens if you were to substitute in and why we end up with just x squared and y squared. If I substitute in the origin, because it's centered at the origin, I would have x minus 0 squared plus y minus 0 squared is equal to my radius squared, which I'll deal with in a second. Sorry, guys. X minus 0 is just x. You are then squaring that value, hence why we get x squared and nothing else. The same is true for y. You end up with just y squared. When you now square your 5 root 3, obviously you just do this on a calculator. Make sure you use your brackets. But remember, this needs to go back to your surds from grade 11. What this is essentially doing is it's separating out, and we're saying 5 squared times root 3 squared, which is 25 times 3, which gives us a radius of 45. If you go square root 45, you will get, I'm also saying 45, that's not 45, is it? 75. If you go and square root 75, you will get 5 root 3. So again, you do not need to show what I've done in purple. You just do it on your calculator. But always remember that you need to be squaring your radius. Okay, so those are nice and straightforward, taking information that we have, and off we go. Question C is a little trickier because it's not giving us any information about our radius, but it is telling us that the circle passes through a point which is 3, 9. Okay. So I would always start by plugging in the information that I know. I know where the center is, so I know it's x plus 5 squared plus y minus 3 squared is equal to, and I don't know what r squared is. But what I do know is that my circle goes through that point 3, 9. So who can tell me, or who wants to give me a suggestion of how I can go work out what my radius is, or what r squared is? So how can I use this information that I have to work out the rest of the equation of my circle? Nice, Leila. Exactly that. We just substitute in a point. It's the same as any other function. Granted, a circle is not a function. We know this, it's a relation. But if we know a point passes through it, we know we can substitute that point into the equation. So I'm now going to substitute in place of 3 and y, x and y, 3 and 9. So I have 3 plus 5 squared plus 9 minus 3 squared equals r squared. Now, guys, remember, you're just looking for r squared. You don't need to go a step further and look for r. We're looking for the equation of our circle. So we can stop once we solve for r squared because that's all we want. So what I mean by that is 3 plus 5 squared is 8 squared, 9 minus 3 squared, 3 squared is 6 squared. And if you add those two together, you end up with 100 equals r squared. Now, remember, you're trying to get the equation of the circle. You've already substituted in the center. You were just looking for r squared. We have that information. You do not need to go and say r equals 10, therefore r squared equals 100. You've got that. If I'd asked you what the radius was, yes, absolutely, you would need to square root. But in the case of what the question is asking me, I needed r squared. So now I know I've got x plus 5 squared plus y minus 3 squared is equal to 100. Because again, the equation that I'm looking at, the equation that I'm substituting into is x minus a plus y minus b equals r squared. Okay, so when finding the equation of the circle, you need to know the center and you need to know the radius squared. Sometimes we give you the radius, sometimes we don't, like in the last question, but as long as you know where the center is, you can substitute in a point that you know lies on the circle, and you can go and solve from there. Okay, so let's take a screenshot and then you're going to try some by yourselves. Remember, guys, if you have questions, you just need to ask. You can put it in the chat, you can unmute yourself, you can direct message me, whatever you're comfortable with, but please do ask. Okay. So I want you guys to try these two questions here. Nice, easy, determine the equation, and then a slightly harder one where I'm not giving you, I don't know why I'm saying slightly harder one, it's not slightly harder. Right, try these two for me. I will give you 5 minutes. You probably don't need 5 minutes. Let's go 3 minutes and then we'll see where you're at. And then we're going to have a look at the answers. Remember, ask if you need help. And you're welcome to put answers in the chat. Hey, Girls, can you just give me a thumbs up if you are done and ready for the answers? or a thumbs down if you need another minute or two. Thank you, Leila. Anyone else? Demiso, thank you. Smutanda, thank you. Okay, if no one's going to say otherwise, I'm going to put up the answers here. Remember, guys, if you're confused about anything, just ask. Alrighty, so if we go and have a look, there are your answers for A and B, nothing too tricky. Question A, very, very much like the question we just had in the last example. I told you where the center was, but I also told you it was passing through a specific point. So you could substitute in that specific point and you could go and work out R squared. The second question, basically the same thing, except for the fact that I said it's passing through the y-axis at 4. And so what that means is you now need to go a step further and realize that you've got a coordinate at 0, 4 that you can substitute in. Right. Sorry, I don't know why my brain had a little fart there, but anyway. So once you know what coordinate you have, you can substitute that in, and very much the same thing. You get the center, you get your R squared, you have the equation of your circle. Right, I'll just wait there for a second or two for you to screenshot. But where things now get a little more complex is if I don't give you the equation in center radius form, and I give it to you in standard form. If you then want to gain information about your circle's center and its radius, you will now need to complete the square. Okay. All right, so that's exactly what this next little sentence is here. Sometimes in order to get the equation of our circle in center radius form, or even just to determine the center and the radius, we need to complete the square. Now, guys, completing the square is not something that you need to be scared of. I know it's not something everyone likes, but honestly, it's so easy. Okay, don't overthink it. Don't try and make it complicated with like minus b over 2 and minus b over 2 squared. And no, don't do that. I'm going to show you how to do it. Obviously, you use a method that works for you. If the minus b over 2, whatever works for you, great. But the whole idea of completing the square is just to create a quadratic where you have brackets squared. But what we need to remember is that anytime we create a bracket squared, we end up with a trinomial. And I'm going to explain all of this as we go along. Okay, I'm going to do the first one not drawn out, but I'm going to do it really step by step so that you can see exactly how we go and complete the square. And then the next one I'll do slightly faster because you can see it's actually not that tricky at all. So if we have a look at this first example here, we want to determine the equation of the circles in the center radius form. And this first one we have is x squared minus 4x plus y squared plus 6y equals 51. So step 1, when you are doing this, is to move the constant to the right-hand side. Now, in this case, it's already on the right-hand side. So I don't need to stress about that. If it wasn't on the right-hand side, I would move it to the right-hand side because remember, you want r squared on the right. That is all your constants squared. Right, so this case, we're good. The second thing that we're going to do is we're going to essentially group all x squared and x terms and all y squared and y terms. All right, I don't know if I've left myself enough space for this, but we'll see how we go. So I've got x squared minus 4x, that's one grouping, plus y squared plus 6y, second grouping, equals 51. Now we know the goal is to have those brackets as an x plus or minus something, a y plus or minus something, and then each of those brackets squared. So this is now in your third step where you complete the square for both x and y. So strange looking m, let's try that again. So essentially when doing this, you're actually completing the square twice. Okay, now guys, the way I complete the square, like I say, super easy. Don't even like think too hard about it. What I do is that first term in your bracket. So I know I'm going to end up with a bracket squared. The first term in your bracket comes from the first term that deals with the squared. So in this case, x squared. Now, all you do is you ask yourself, what am I multiplying together to get x squared? X. That's it. X times x is x squared. Then what you need to do is you need to take the coefficient of your x term. Let's actually maybe get a color going here. So we take the coefficient of our x term and we halve it. That's it. So half of -4 is -2. Bracket done. I'm going to do exactly the same thing with y. To get y squared, I say y. So remember, it's going to be the bracket squared. I'm going to take the coefficient of y, which is +6, and halve it. So that becomes +3, and it's squared. Now, this is where completing the square maybe trips us up a little bit. What we need to remember is that in each case, you've now got a bracket squared. So x minus 2 squared means x minus 2 times x minus 2, which if we expand that is x squared minus 4x plus 4. Now, the x squared minus 4x, that's what you had in your original bracket. But now all of a sudden you've added 4. So all you do, and I have some regrets about how much space I've used here. Move this over a smidge. So all you now do on the right-hand side, because you added 4 on the left, you add 4 on the right. That's it. The same thing is going to be true for y. So for this y plus 3, cool. This y plus 3 squared situation, this is not going to work. So we're just going to go the other way. You have done exactly the same thing. You have now got y plus 3 times y plus 3, which if you expand that is y squared plus 6y plus 9. And so if you have a look, you've added a 9, because there's the 6y. Yes, guys. Because there's the y squared plus 6. You already have it, but now you've added a 9. So on the right-hand side, you just add 9. Now, where the 4 and the 9 are coming from are basically you taking this value that you've written in the bracket and squaring it. So think of it like this. If we were to take -2 squared, -2 times -2 is 4. If we take +3 squared, 3 squared is 9. So that's where those values have come from. I haven't made them up. I haven't sucked them out my thumb. They've come from somewhere. And they come from the fact that because I now have a bracket squared, I have added an extra term on the left-hand side. So I've got to add that term on the right-hand side as well. And now all you do is you simplify. So we have got x minus 2 squared plus y plus 3 squared. And on the right-hand side, we've got 51 plus 4 plus 9, which gives us a radius squared of 64. Okay, so when completing the square, excuse me, don't overthink it. Don't overcomplicate it. Don't try and outsmart yourself. You are quite literally bracket squared, half of your coefficient in each bracket, and on the other side, you're squaring that half value. That's it. And that all comes down, or all is a result of the fact that you have added extra terms on the left, so you've got to add those terms back on the right to keep your equation balanced. Okay, so if we look at B, I'm going to do exactly the same thing as English, except without all of the additional working out. So I've got my x squared minus 6x plus my y squared plus 4y is equal to, I move the constant over, so +5, and now I complete my square. Okay, so in my bracket, x minus 3 squared, because I'm halving -6, plus y plus 2 squared, because I'm halving 4, is equal to 5 plus, I take -3 and I square it, so 9. I take +2 and I square it, 4. So I get x minus 3 squared plus y plus 2 squared is equal to 18. And you've got the equation of your circle. You know where the center is, you know where the radius is. Happy days. So guys, when completing the square, don't overthink it. Don't overcomplicate it. Don't try and make it more than it is. Literally just halve the coefficient and then square that value on the right-hand side. Okay, so if we have a look at example C here, what we need to be careful of is the fact that you just have a y squared. So when I group my terms, I've got x squared minus 6x plus y squared, which doesn't have a partner, equals -1. Now that's fine. We know what that means. If there's just a y squared, it means that the center of my circle has a y coordinate of 0. So in this case, I'm lucky. I actually only have to complete the square once with x. So that gives me x minus 3 squared plus y squared is equal to -1, and we are adding a -3 squared, so you're adding 9. You don't have to write the -3 squared if you don't want to. So we've got x minus 3 squared plus y squared is equal to 8. -1 plus 9 is 8. Done. Okay, so the completion of the square, sorry guys, does not need to be overthought. It is very, very straightforward. If we have a look at question D, and sometimes we do throw a little curveball, question D, again, don't overthink it. If you have a look at everything going on the left-hand side, I'll highlight the left-hand side for myself. Everything there is divisible by 2. Oh, golly, I'm having a time. Excuse me, I do apologize. Everything on the left is divisible by 2. Make your life easier. Divide everything by 2. So that means I've got x squared minus 2x plus y squared minus 3y is equal to 5 over 2. Don't forget to divide that 5. But now this is an easy completion of the square. Group your x terms. Group your y terms. Your constant is already on the right-hand side, so that's fine. And now I do exactly the same thing. X minus half of -2 is 1 squared, plus y minus half of 3 is 3 over 2 squared is equal to the 5 over 2. Now remember, we're taking -1 squared, so we're going to add a -1 squared plus a -3 over 2 squared. And then quite literally just type that in your calculator. You do not need to go and do that in your head. So if you do that all on your calculator, you will get what your radius squared is. So we've got x minus 1 squared, strange looking plus y minus 3 over 2 squared is equal to 23 over 4. So not the nicest looking radius. If you square root that, it's not going to be a nice value, but you still have all the information that you need. Nothing there is ambiguous. You know where the center is, you know where the radius is, and you've completed the square. So like I say, sometimes you do throw a little curveball and there's fractions involved, but it doesn't change what you're doing. You are still halving the coefficient and then taking that half and squaring it on the right-hand side. All right, so let me just make this a tad smaller, probably a tad more. Right, so take your screenshots of example 3, and then you're going to try by yourselves. And guys, this is probably the most complex part of finding an equation in terms of if you have an equation and you need to put it in center radius form, it's completing the square. All the other algebra that we do in analytical is not complex algebra. It really isn't. Completing a square is probably the most complex method of algebra that we use here. So as long as you get completing the square down and you practice it, you're fine. Like I say, if you have other ways to do it, absolutely go for it. There's nothing wrong with not doing it the same way as I do it. I just find this the easiest method. But if you don't, use what works for you. Okay. So I want you to try these two for me. Again, we're wanting to write it in a specific format because the question is asking us to determine the coordinates of the center and the radius of the following. So that means you have to put it in center radius form. You have to complete the square in order to figure out what the center and what the radius is. Okay, I'm going to give you 5 minutes. Again, I don't think you need 5 minutes, but I'll give you 5 minutes and then we'll have a look at the answer. Right, again, can you give me a thumbs up if you are ready for the answer, or a thumbs down if not? Thanks, Leila. Measles. Okay, so Tanda. Okay, another minute or two. That's fine. Awesome. Okay, guys, let us have a look-see. Okay, so again, A and B, nothing too complicated there. Can we see the whole answer? Yep. All right. So complete the square, nothing tricky in both of them. That's it. The only difference with these two is I had now asked the additional question of I wanted the center and the radius, so you do need to have gone and told me what the center and what the radius is for each of these. But once you've got the equation in the format you want it, doesn't really take much. Alrighty, not a great color that I made a choice to use there. Okay, so completing the square, very, very useful. I'll just wait 2 seconds if you didn't take screenshots, and I'll have a look at our next example. Alrighty. So example 4, we'll get to example 5 hopefully. If not, it's not the end of the world. It's an extension question. It says if the radius of the circle defined by x squared minus 2x plus y squared plus 4y minus k equals 0 is 5, determine the value of k. All right, so let's just read this slowly again. It's saying if the radius of our circle, which has the equation given here, is 5. So it's telling us what the radius is. So what we need to actually do here is we need to start making the connections with the information that we've been given. So we've been told the radius is 5. So maybe try the other way. It's not going to enjoy that. Which means that r squared is equal to 25. And just something to think about. You know, might be useful, might not be. Probably is, because we're looking at the radius. And in the equation that we've been given a minus k. Now, minus k represents a constant. Once we know what k is, it would be minus 2 or plus 7 or whatever. The constant. K is relating directly to our radius. So what we are going to have to do here is complete the square to get what the radius squared expression would be. So we group our terms, x squared minus 2x. If you can complete the square in sort of the first step, that's awesome. Can't even write, so that's cool too. Yes, let's try again. X squared minus 2x plus y squared plus 4y is equal to k. So remember, we bring that constant over. We now have x minus 1 squared plus y plus 2 squared whoops, equals k. And remember, now we add on to the right-hand side what we added on the left. So I added a 1 squared, which is just 1, and I added a 2 squared, which is 4. So I've got x minus 1 squared plus y plus 2 squared is equal to k plus 5. Now, what you need to remember is that in this form of my equation, in the center radius form, this k plus 5 represents r squared. So in this format of my circle, x minus a squared plus y minus b squared equals r squared. The right-hand side is r squared. And that's great because I actually have information about my radius. I know that my radius was 5, so r squared is 25, and that is represented by k plus 5. So I can now go and solve for k and say that k must be a value of 20 if this is the equation of my circle and if the radius is 5 units long. Okay, so, sorry, just remember that when you are given a slightly more complex question, look carefully at the information you've been given and see how it relates back to what you know. You know the general formula of your circle, you know the center radius formula of your circle. If you've been given information about your radius, get it in the form that gives you r squared, because you can directly link those two bits of information, exactly like we did here. Alrighty, so slightly more complex question, nothing too tricky, but use the information that you've been given to answer it. So if we have a look at example 5, we're probably not going to get to the UTRI, but that's okay. It says, for what values of k will the equation x squared plus 6x plus y squared minus 2y plus k equals 0 define a circle? So this is a slightly new one. If we are defining a circle, what we need to essentially realize is that that means that r squared must be greater than 0. Let's try that again. Now, why, you might ask? Well, in order for us to have a circle, we have to have a radius. Otherwise, you've just got a dot at the center. There must be some distance from your center to your circumference in order for you to create a circle. For that distance to exist, r squared must be greater than 0. And again, we're going to use this information to go and find k. Now, because this is information about my radius, I'm going to have to complete the square again in order to use the definition of a circle, or the defining characteristic of a circle. So our brackets, x squared plus 6x plus y squared minus 2y, bring your k over, so equals negative k. That's fine. That represents my r squared. And so now I complete the square. X plus 3 squared plus y minus 1 squared is equal to minus k. I'm adding 3 squared, so 9, and I'm adding negative 1 squared plus 1. So I have the equation of my circle in terms of k. Technically, I know where the center is, and I know the expression that represents my radius, minus k plus 10. Now remember, this is r squared. That's what the right-hand side represents. I can now use that information. I know that minus k plus 10, the expression that represents r squared, must be greater than 0. And so therefore, when I solve my equation, k is less than 10. If you don't want to solve it like that, that's absolutely fine. You can go ahead and leave the negative k on the left, bring the 10 over, making it negative. Just remember, when you divide both sides by negative, your sign flips. So you end up with exactly the same things, whatever you're more comfortable with. But if we are using, or if we're going to use the characteristic that defines a circle, that is the fact that your r squared must be greater than 0. You have to have a radius. And so once again, because we have information about the radius, we need to get our equation in center radius form so that we can actually go and link the two bits of information. All right, guys, so slightly more complex questions, nothing too hectic. Again, it's just the ability to complete the square is very, very useful. All right, so take a screenshot of those two. And then we're not going to have time to do the U try. I'll put it up there if you want to have a go at it. I can always put it up next lesson to start off with. So there's the U try questions if you would like to try them. But once you've got your screenshots, you're welcome to head off for the evening.